All right, so parallel and perpendicular lines. Let's talk for a minute about those. Parallel lines are two lines that whenever you graph them on the same graph, some people say when you graph them on the same plane, P-L-A-N-E, then they never ever cross each other. So they're like that. They're like railroad tracks, okay? Those don't cross each other. All right, then you've got perpendicular, and perpendicular lines, and keep in mind this is just kind of a rude little graph here, but pretend like that's a 90-degree angle there. So perpendicular lines create there's 1, 2, 3, 4 90-degree angles whenever they cross each other. They're very specific, like perpendicular. Not all graphs are either parallel or perpendicular, okay? So they may have angles that don't create 90-degree angles, in which case those lines just simply cross each other, all right? So I want you to realize that not all pairs of lines fall into these two very specific categories. All right, so check out these two lines. Now, they both have the same slope, so let's look at that. Let's count. All right, so if I put a dot right here and I put a dot right here, I could count from here to here. So I would go up 1, 2, and then to the right, 1, 2, 3, 4, 5. Okay, so the top line has a slope of 2/5. Now check out the bottom line. If I put a dot right here, and this dot also lies on the line, and then I want to count on that one. I go up 1, 2, to the right 1, 2, 3, 4, 5. Okay, so that line also has a slope of 2/5. Parallel lines have the exact same slope. They have different y-intercepts. Notice the y-intercepts are different on these lines, but they have the exact same slope. All right, so what about vertical lines? Or if we're talking about horizontal lines, what about horizontal lines? Well, check this out. So these lines are vertical. These two lines are vertical. This one's vertical, this one's vertical. And both of their slopes, as we learned from a previous lesson, are undefined. And so they are parallel. They have the exact same slope, and they are parallel. Also, same thing goes for horizontal lines. If we were dealing with horizontal lines, all horizontal lines have a slope of 0. So therefore, all horizontal lines, as long as they don't sit on top of each other, are parallel. All right, so we're going to graph these equations on the same graph to determine if they are parallel. Now, the thing about this top one, this top equation, I've got the slope staring at me, and I've got the y-intercept staring at me. So my slope on this top one is -2. My y-intercept is at 0, 3. We learned that from a previous lesson as well. So if I graph this, I go up 1, 2, 3. Now remember, all slopes or all whole numbers can be turned into a fraction by placing that number over 1. So from this dot, I'm going to go down to right 1, and I can keep doing that. I'm not going to, but I could. All right. Now this bottom one, the slope and the y-intercept are not staring at me, so I need to turn this into slope-intercept form. So what I would do first is I would subtract 2x from both sides. That goes away, so I've got y is equal to -2x minus 1. Okay, so my slope is -2 or -2 over 1, and my y-intercept is at 0, -1. Okay, so I'm going to graph that one in a different color. 0, -1 is right here. And then I go down to right 1, down to right 1, down to right 1, all right? So check that out. Notice I didn't use a ruler, and I'm really sorry about that. But the slopes are the same. The slopes are the same. the y-intercepts are different. And so it's important that you understand that the y-intercepts have to be different. Otherwise, if it's the same slope and the same y-intercept, it's the same line. That's not parallel, okay? It just sits on top of each other. All right, but in this case, slopes are different, y-intercepts are different, so the slopes are parallel, or the lines are parallel to each other. All right, so on this one, we're supposed to use the slopes and the y-intercepts to determine if the two lines are parallel. I'm going to start with the bottom one because that's the easier one. So this one has a slope of -2/5, and it has a y-intercept of 0, -4. Okay, so slope, once again, slope is -2/5, y-intercept is at 0, -4. All right, this one is the one I can't tell, okay? So I'm going to have to turn that into slope-intercept form in order to be able to tell what the slope and the y-intercept is. So I've got my equation at 2x plus 5y equals 5. So I want to subtract 2x from both sides. That goes away. I'm left with positive 5y is equal to -2x plus 5. Notice I put the x term first. That's because I want it in slope-intercept form so that I can tell what's going on here. Now I divide everything by 5. So I end up with an equation of y is equal to -2/5 x plus 1. All right, so I know my slope is, my slope is -2/5, and my y-intercept is at 0, 1. So these guys have the exact same slope, but different y-intercepts. That means they are parallel. All right? Okay, so what if you don't have an x in your equation? What if all we have are y's? So if you go back to a previous lesson, remember y equals -1. I'm just going to kind of rudely draw this. Y equals -1 looks like this. Y equals 3 looks like this. Okay, so notice that even those are parallel to each other. So all horizontal lines have a slope of 0. And so yes, these two lines are parallel because they have the same slope. All right, so look at these. X equals 4 and x equals -5. Again, just going to quickly just sketch these. X equals 4 looks like this. X equals -5 looks like this. Check those out. Now they both have a slope that is undefined. And since their slopes are both the same slope and they're not the same line, that means they are parallel. All right, so let's take a look at these real quick. Okay, so this first line, y equals 2x minus 3, I have a slope of 2 and I have a y-intercept of 0, -3. Okay, this one, this equation, I don't know what the slope and the y-intercept is. When it's written in standard form, by the way, that is called standard form, we don't know yet. Okay, so I'm going to add 6x and I'm going to divide by 3. Everything gets divided by that number. Okay, so I have a slope of 2 and I have a y-intercept of, I have the exact same slope and the exact same y-intercept. These lines sit on top of each other. So I would say that they are not parallel because they are the same line. And to graph these, you would do this. 0, -3 first, and then do your slope. Up to right 1. All right, so they are the same line. They are not parallel to each other. They are the same line. All right, so I just really, on this page, I wanted to show you what perpendicular lines look like. Not all lines that cross each other are perpendicular. These are very, very, very specific, okay? These are specific to creating a right angle, or actually 4 right angles when they cross each other. So there's one right angle, there's another right angle, another right angle, another right angle, okay? That's what perpendicular lines do. They create 90-degree angles where they meet. Okay, so you might want to just hit pause here and read through what I have here about the definition and the slopes, and then we'll talk about it on the next slide. I lied. We're going to talk about it on the next slide. Okay, so the only exception to my previous rule is I keep talking about opposite reciprocals, opposite reciprocals, opposite reciprocals, and that's very true for perpendicular lines, with the exception of vertical and horizontal lines. Okay, a vertical line is perpendicular to a horizontal line. We'll see that coming up. All right, so on this page, we're going to determine, notice that on parallel, we talked about the slope and we talked about the y-intercept, but in perpendicular, never do I even mention the y-intercept, because I don't care. The y-intercepts can actually be the exact same. It does not matter what the y-intercept is on a perpendicular line. What matters is the slope. Okay, so let's look at the slope of this line right here. I'm not even going to write down the y-intercept. The slope is -5. Now, if this line over here is perpendicular to this line, by the way, I want you guys to know that the symbol for perpendicular is an upside down T with a little box in the corner. That's the symbol for perpendicular, okay? I want a slope that says +1/5. Keep in mind, perpendicular lines have slopes that are opposites, so one is negative, one is positive, and then you flip-flop the top and the bottom. And this line is really written over 1. We just don't usually write that. We don't usually write that, but it is there, okay? We just don't, like I said, we don't write it. So one is positive, one is negative, and you flip-flop top and bottom. So that's the reciprocal part. All right, so let's look. Let's see, because I really can't tell just by looking at this. The first thing I would do is I would subtract x from both sides. And remember, that's a -1 in front of that x, okay? Then I would divide everything by -5. And so I end up with y is equal to a negative divided by a negative is a positive. So I end up with 1/5 x minus 1. All right, so the slope of this line is 1/5. So m equals -5 is perpendicular to m equals 1/5. Yes, these lines are perpendicular. All right, both of these equations are in standard form. So let's put them in slope-intercept form and see if they're perpendicular. So I'm going to subtract 7x. I end up with 2y is equal to -7x plus 3. I divide everything by 2. And I end up with y is equal to -7/2 x plus 3/2. Okay, so my slope on this one is -7/2. If this line is perpendicular to this line, then I would need a slope that is, take away the negative sign and flip-flop your numerator and denominator. Okay, so we're hoping for this on this line right here. Okay, so let's take a look. Let me just do something real quick. Okay, I'm going to move this over here. Okay, so remember this right here is what we're hoping to get. Okay, so I would subtract 2x from both sides. I end up with 7y is equal to negative 2x plus 5, and divide everything by 7. So I end up with y is equal to negative 2/7 x plus 5/7. So my slope on this one is negative 2/7. Nope, it's not. They are not perpendicular. Here's why. This one is negative, and this one is also negative. Remember, one has to be positive and one has to be negative. The only exception is a vertical or a horizontal line, okay? So we wanted positive 2/7 for it to be perpendicular. This ended up being negative 2/7, so I would say not perpendicular. All right, so that's it for parallel and perpendicular lines. If you have any questions, don't hesitate to contact me.